Okay, so homework 8 is about determining the slope of a line. Okay, slope of a line is what makes the line go up or down, or go straight across, or just straight up and down, horizontal or vertical. Okay, we are going to use this formula right here to find the slope between 2 points. All this means is this is the x value of the first point, y value of the first point. These stand for the second point. In calculus, you'll see this called delta y, meaning the difference of your y's, over delta x, which is the difference of your x's. We know slope is rise over run. Well, rise goes up and down. That's why you put the y's on top. The run goes across, which is your x values, or your x-axis. Okay, so if you're given 2 points, find the slope of a line passing through the given points. Here's what I do. I tell you to connect the first ones, connect the second ones, and then I circle this one. Because we're going to use m equals y2 minus y1 over x2 minus x1. So what I'm going to do is I circled this because that's my y2. It's my y of my second point. Minus my y1, which is 3. Then if I started with my 8, I have to start with my 1 on the bottom. 1 minus a negative 2. This minus sign comes from the formula, so be real careful, especially when we're dealing with negatives. Double negative becomes a positive, so we have negative 11 over 3, and just leave your answer as a fraction. Right here, connect the first ones, connect the second ones, circle that one. So we're going to do 7 minus its partner, which is 7 minus 5. 3 minus 3 on the bottom. So we have 2 divided by 0. 0 underneath is undefined. So this has an undefined slope, because we cannot divide by 0. Okay. These are the 2 problems I told everybody, just memorize them or figure something out to remember it. This is how I learned it, by doing table of values. Okay. This says no matter what x is, y is always 4. So put a bunch of 4s underneath your y. I don't care how many. I would do more than 2. I would do 3, 4, 5, however you want. This says no matter what, x is a negative 3 right here. So again, put a bunch of negative 3s under your x. Now, when this says y is 4, it doesn't matter what x is. You can use 0, 1, 2. I'm going to throw in a negative 3. So now, 0, 4, 0 up 4 right here. Right 1 up 4. Right 2 up 4, left 3 up 4, and this is a horizontal line. That's what I was saying. You can memorize that a y equals some constant is a horizontal line, okay? So that means an x is going to be a vertical line at negative 3. But you can just graph points. Again, you can pick whatever numbers you want for your y, but x is always negative 3. And then let's say negative 3 here. Okay, so negative 3, 0 is here. Left 3 down 1. Left 3 up 2. Left 3 down 3. 1, 2, 3. So you have a vertical line. And we will deal with this all semester long. So if it's a y equals, it's a horizontal line at that number. If it's an x equals, it's a vertical line at that number. Okay? All right. Right here, finding the slope, what you want to do is pick 2 good points. Okay? When I talk about good points, they fall in the corners of these squares. Like right here, that's a good point. This is not. Neither is this one. This one is. This one's not. That one's not. There's one over here too. No, no, and yes right here. Now, if they give you a line like this, I know it's positive because it goes uphill. Positive people bring you up. And by the way, slope is, oh, and I forgot to do the slope. I just showed you how to do these. I'll come back to this. Okay, if you were going to find the slope of two of these points, this one here is 0, 1. This one is 1, 2, 3, up 2. And you can even use this one of negative 3, 0. It doesn't matter. Just pick two of these points. I'm just going to pick these. So I have 0, 1 and 3, 2. You can do the same thing that you did up here. Connect your first ones, connect your second ones. 2 minus 1 over 3 minus 0. And you get a positive 1/3. 2 minus 1 is 1. I started to put a 2. And you get a positive 1/3. Now, if it's like this, you can actually count. You can count rise over run from one point to another. Here's one point. You go up 1, right 3. So you went up and over 3. Right 1, up 3. Well, let's try this again. Up 1, right 3. Or you can do it between these 2 points. Up 1, over 3, 1/3. You can even go from here over to here. We went up 2 over 6. 1, 2, 3, 4, 5, 6. Rise over run, 2 over 6, which reduces to 1/3 as well. Okay? So it doesn't matter how you do it. Now, we never did find the slope too. I should do that. Okay? One of these has an undefined slope. The other one has 0 slope. So you can pick two of your points. I like to use the one with 0. So I'm going to use 0, 4, and 1, 4. You didn't have to. You could have picked any of these. Connect here, connect here. Start here. It's 4 minus 4 over 1 minus 0. So you get 0 on the top, 1 on the bottom, which gives you a 0 slope. So this has a 0 slope. This one's going to be undefined slope. But to prove it, let's just pick these two. Negative 3, negative 1, and we'll pick negative 3, 2. Connect your first ones, connect your second ones, start with that one. 2 minus its partner of a negative 1. Negative 3 minus from the formula its partner of negative 3. Double negatives become positive. We get a positive 3 on the top and we get 0 on the bottom. 0 underneath is undefined, so it has an undefined slope. You have to know that word. This has a 0 slope, this has an undefined slope. Okay. Graphing a line through a given point with a given slope. Write the equation in slope-intercept form. Slope-intercept form is y equals mx plus b. Okay. Now, let's graph it first. It passes through this point, so we're going to go left 2, up 1. That's the point, negative 2, 1. Now, our slope is negative, so we are going to go down 2, and I teach it go down, but you always go to the right. If it's negative, you go down. If it's positive, you go up. But you always go to the right. So from here, you go down 1, 2, right 3. Down 2 from our new point. Let's go do it again. 1, 2, and right 3. And now you draw your line between them. And I gotta find something to do a straight edge with. I wasn't prepared for that. You go until you run out of room. And notice how big I make my line. Okay, now we can't write it in. We know the slope, but we don't know the y-intercept because we don't know what this number is. It's in between here. It's in between 0 and negative 1. So here's what you do. These x's and y's stand for a point, any point on this line. Well, we know one of the points is this. So this is my x and this is my y. So I'm going to plug 1 in here. I'm going to plug in negative 2/3 for my slope because it's given. I'm going to plug in negative 2 for my x. And we don't know b, which stands for the y-intercept. This is our slope, this is our y-intercept. Okay, so I'm going to multiply these two together. That's going to give us a positive 4/3 plus b. I'm going to subtract 4/3 from both sides. Sorry if you can hear the football game in the background. I forgot to turn it down. So we have b on this side. This is 3/3 minus 4/3 gives us a negative 1/3, which looks like that would be right. Okay. So now we know our y-intercept is 0, negative 1/3. Not that you had to know that, you just need to know that y-intercept is a point, okay? But we have to write the equation in slope-intercept form. Well, this is slope-intercept form, where we know our slope is negative 2/3, x plus, well actually in this case it's plus a negative 1/3, but the best way to write that, the correct way, is negative 2/3 x minus 1/3. Okay, and these x's and y's stand for all these points. If I plugged a positive 1 in here, I would get a negative 1 out, and that's what that point is. Okay, if I plugged in any of my x values, like this one right here, if I plugged in a positive 4, I would get 8/3, negative 8/3 minus 1/3, which gives us negative 9/3, which is negative 3. So that's what all the x's and y's stand for. Okay, right here, this is really over 1, and you need it like that for when you graph the line. You graph this negative 1 down 4 first. Now, because this is a positive slope and positive people bring you up, you're going to go up 3, and you're still going to go to the right. See how the bottom numbers, you always move to the right? So from here, make sure I did that right, negative 1 down 4, okay? You're going to go up 3 over 1. Up 3, 1, 2, 3 over 1, and I can go up more, so I'm going to go up one more time. Up 3 over 1, and then I'm going to draw my line. Now at this point, I can actually write it in slope-intercept form. Because I know my slope, I know it crosses the y-axis at 0, negative 1. So I can go ahead and write y equals my slope, which is 3x minus 1. Now, if we did it the same way I did over here, I can prove it, okay? I can plug in, this is y equals mx plus b, okay? So I'm going to plug in a negative 4 for y, 3 for m, negative 1 for x, because this is my x and this is my y right here, plus b. So I have negative 4 equals negative 3 plus b. I'm going to add 3 to both sides, and I get negative 1 equals b. So I have y equals, my slope is 3, x minus 1. Okay? Alright. I'm going to go pause that football game because I don't know if you can hear it, but I can, and it's loud. Hold on just a second. Sorry. Okay, for this one, it's compute the average rate of change. It's the same thing as slope, except for lines have slopes, okay? So if we had a straight line, that has a slope. Well, now they're going to give us a curve. This blue one is a curve. And we got to find the average slope between these 2 points, okay? We have these 2 points. We draw what's called the secant line, not that you have to know that. And it's called the average rate of change between these, because it's the slope of that secant line, okay? Now don't let this confuse you here. It's the same thing as what we were doing here. Remember, this is the output, same thing as our y2. This is our output y1. Still, it's the same thing. Okay, so now, see how we have a curve here? It says determine the average rate of change from this point to this point. So you have the secant line that goes like this. Okay, and you're wanting to find the average rate of change between those 2 points. We're going to call it AROC because I don't feel like writing all that out. And what I'm going to do is same exact thing, connect the first ones, connect the second ones, and I get 2 minus its partner of 0, 0 minus its partner of a negative 1.5. Double negative becomes a positive, and we get 2 over 1.5. But the problem with this is that that's a bad way of writing our answer, okay? You don't want a fraction within, a decimal within a fraction. Okay, so we need to change that. So on your calculator, you're going to hit 2 divided by 1.5, math, fraction, and you're going to end up with 4/3. I don't have my calculator that has fractions on it, so I have to just do this on my phone and then convert it to a fraction, or I would show it to you on my calculator. I don't think, yeah, I don't have a graphing calculator on me. Let me see one other thing. I may have something on my phone that might do fractions. Hold on. I don't know if this will do it, but we'll see. This one, here we go. So, nope, that isn't going to do it. Sorry. I'm trying to find something on my calculator that I can show you. Maybe this one might. Maybe. Okay, we'll see. We'll try it. No, I don't even know how to clear this one. Let's try that again. There we go. 2 divided by 1.5 equals, maybe, it gives me that, which I know is 4/3. Oh well, sorry, you've got your calc. Wait, maybe, hold on. I think I may have found it. Yeah, let's try this again. Let's see if I put it right here. Maybe. Obviously, I don't use this much, or I've never used it. It's still not giving it to me. I just know that's the answer. Sorry. Okay, now this is what it's going to look like on your test. Except you're not going to look at a graph. It's really going to be like this down here. But it's actually easier on a graph because it already gives you the answer. When x is 0, we need 2 points. When x is 0, what is y? So you go over here and you say, okay, here's x is 0, y is 2. So one of our points is 0, 2. This says when x is 2.5. Well, let's look at our graph and see what y is. Here's 2.5, of 1. Find the average rate of change between those 2 points. Because again, it is a secant line. Whoops. Hold on, I gotta move my paper so I can draw my line, if I can get it straight. Okay, it's that line right there. So it's not really a slope of the curve, it's the slope of that secant line. So we call it the average rate of change. Connect the first ones, connect the second ones, and we get 1 minus 2 over 2.5 minus 0. So we get a negative 2 on the top, and negative 1 on the top, and 2.5 on the bottom. So let's change that to a fraction, because again, we have that decimal within a fraction. We don't like that. And it's going to give us, I'm thinking, sorry. I really wasn't prepared to do this video, apparently. Hold on just a second. It is negative 2/5. Another way, I know this is, I don't know if you'll understand this, but the way I did this without a I tried it on a calculator and it wouldn't work. But what I can do is multiply the top and the bottom by 10 here, and I get 20 over 15, and then that reduces to 4/5. Here, to get that to move one place to the right, I multiply the top and the bottom by 10, and I get 10 over 25, and then 5 goes into that 2 times, into that 5 times, so that I know that's right. Okay, this is what's going to be on your test. Okay, you will see this again. So the thing is it's not that difficult, but you might forget what to do. So really pay attention. Put an asterisk or something to tell you got to study this. Okay, so they give us x values of 2 and of 4. So let's first deal with this 2. We need 2 points. We need 2 and whatever our y is, and we need a point that starts with our x value of 4 and whatever our y is. But they give us a function. So what I can do is take this 2 and plug it in for x. We've already done these problems. We did these problems back in maybe homework 6, maybe. I can't remember exactly. But I think it was homework 6 when we started functions, where you take this 2 and you plug it in. It's our input, which our input is always our x value. And whatever it gives us is our y value, or our output. So we're going to plug in 2 wherever we see x. When you do this, this gives us 4, 8. This gives us 8. Plus 6 is 14. Minus 4 gives us 10. So one of our points is 210. Now we got to find f of 4. Again, the same thing. Plug it in wherever you see an x. 30 times 4 minus 4. This gives us 16. 16 times 2 is 32. Plus 12. That's going to give us, let's subtract 4 here. This is going to give us 44. Minus 4 gives us 40. Now you can do this on your calculator. I'm just doing it by hand. If you can hear that noise, it's fireworks going off at, sounds like gunshots. It's actually fireworks at the high school, because apparently Anderson County just scored, and they always shoot off fireworks when they score. Anyway, we got all kinds of noises at my house right now. So our average rate of change, now we have 2 points. Do just like we've been doing. We're going to do 40 minus 10 over 4 minus 2. So you get 30 on the top, 2 on the bottom, so our average rate of change is 15. Okay, and the last one. It's an application problem. It's not that hard. It's the same exact thing that we've been doing. It says Hong is cooking a roast. The table below gives the temperatures R of T of the roast in degrees Celsius at a few times T in minutes after he removed it from the oven. Find the average rate of change from 30 minutes to 50 minutes. Well, now notice what happens. He takes it out of the oven, and this is the temperature. And what happens is as he lets it rest, the temperature goes down. The roast starts to cool off. So if it's going down, our average rate of change is negative. Well, at 30 minutes, it's 109.3 degrees. Okay. Then at 50 minutes, it's 51.3 degrees. Now find your average rate of change. 51.3 minus 109.3 over 50 minus 30. On the top, we're going to get 0. We get 58 on the top. We get 20 on the bottom. The only thing here is this is a word problem, and that doesn't make sense to us. So we have to actually change it to a decimal. And we're going to get 2.9 negative, this is a negative, sorry, 2.9 degrees. What that is it drops 2.9 degrees every minute. That's what the average rate of change is. It's dropping that. Anyway, there's homework 8.